Okay, we are live. Welcome everyone to this live stream of the week. And I'm super excited to be here with Sumeet. I hope I'm pronouncing correctly. Sumeet, you want
Mhm.
to quickly introduce yourself?
Yeah. Hi, Francisco. My name is Sumit, and like currently I'm building Chain, a project incubated by another mind. So previously I was in academia. I did my PhD in theoretical physics. I was working on black holes and quantum gravity stuff. And then after I
Oh,
finished my
nice.
PhD,
Yeah.
I entered I got involved into machine learning and AI, and then in crypto, and
Hmm.
then I became part of another mind. And I was focused on working on agentic workflows and stuff like that because I always wanted to build towards an autonomous future where everything is, delivered to us in an autonomous fashion just by understanding our intents. And then for
Mm,
that, having multi-agentic workflows and like having proper accountability and verifiability is crucial.
yes,
This
very
this
cool.
kind of like foundations is what led us to build Chaos Chain, and Chaos
Nice,
Chain is a
nice.
journey towards that future.
Nice. So, very cool, very cool. You need to explain me a bit better. That's super exciting from black hole to kind of like, Web3 and why this interest? Because it's funny because I don't know a lot of people know it, but I'm actually a mechanical engineer, right? And then I went
Ah,
into
nice.
software for masters and stuff and fluid dynamic from the start. And it's very cool also like to hear, your journey and why Web3. I assume it's more about like permissionless, open source, but let us know a bit the story here.
hmm Yeah, so I'm just a curious person. Like I want to, understand the universe in a fundamental way. So that has been always my goal.
Mhm,
And the best tools that I thought about like 20 years back was like to, use mathematics and physics, to explore the universe and like understand the truth. And
mhm.
truth should be reproducible. So because it cannot be, it should be replicatable. So you should be able to, like, irrespective of, like where you are, what time it is, you should be able to reproduce, for example, Newton's laws of physics. And that's how reproducibility is how you get to the truth. And then physics
100%.
is one, right? Physics is one way to do that, right? And then I always found this burning mysteries of the universe, like black holes being like one of the most mysterious object out there, and
Mhm.
then also origin of universe and what happens at very small scales, like especially quantum scales, like how does gravity, behave at those scales? So this will like questions that kept me driving forward for a very long
Nice.
time. And so it keeps the fire burning.
Yeah, of
So
course, of course.
uh,
But curiosity is everything, right? Curiosity
yeah,
is
yeah,
everything that pushes ourselves forward.
yeah, exactly. So that's why then I was pursuing, a PhD in theoretical physics to understand uh, what we have been understand about the universe and like what is that we can do and how we can improve our knowledge and everything. So uh, then reality kind of started hitting me in the sense that especially this domain of quantum
Mhm.
gravity and black hole physics, they're highly theoretical, and it's just very hard for us to do any experiments. So if you can't conduct any experiment or if you can't do any observations, it's really hard to make any progress. Now, 100
Yes.
years back, like quantum mechanics really, quickly evolved, and we developed so many cool technologies, and then of
Mhm.
course many important concepts of science based on that. And the reason being, like, it wasn't just theory. There were like parallelly experiments which were taking place, which were quickly filtering out like infinite amount of other theories that were coming in. So unfortunately, for quantum gravity, we don't have that kind of technology that allows us to do any experiments yet. Hopefully, soon in the future, right?
Mhm.
So I came to
Yeah.
this realization then that in last 100 years, actually, quantum gravity, like we haven't made significant progress. Okay,
Mhm.
and these are the fundamental reasons for that. So how else we could, work on this or like try to understand this mysteries or the questions about the universe, you know,
Mhm.
without, like being stuck in the theoretical mechanics
Mhm.
of action principle and path integrals and stuff like that.
Mhm.
So, uh, like AI is one hack that could allow us basically to shortcut our way, right? Like to understanding these problems.
Mhm.
Because if we can't build like super large colliders or like something which we can't even imagine, like some next like future tech, like which would allow us to do experiments, right? So th
Mhm.
those things seem right now unfeasible. We don't know. So either we need like really, really high tech, which we can't even imagine right now, or we need an Einstein. So, so
Mhm.
unfortunately, we don't have either of these on this planet right now.
Mhm.
But then with what we have is this emerging tools based on like various AI models, right? So okay, LLM is one, then you have computer vision, and then like of course like machine learning has been around for a very long
Mhm.
time and it's been extensively used. So we could, of course, like keep building and working on systems that could understand the physical world, just like we as humans do, and build this world intuition, world models with like physical intuition and all that of how everything works, like how fundamental physics works and stuff like that. And that kind of artificial intelligence, hopefully will help us, like go towards this difficult problems.
Nice, nice. And I think it's also like a perfect kind of like segue, right? Because we need AI obviously to solve some of those specific kind of like challenges. And I think also the fact that it's first fully open source, fully kind of like permissionless. And I'm very excited. We did the live stream last week with Mark on kind of like
Mm.
explaining, breaking down 8004 for the people also like hearing this a good kind of like way and to summarize and see what is happening. Um, but let's give a bit context, right? Like what is kind of like, Couch Chain, you mentioned before, it's incubated by Nethermind. So easy support, like, why 8004 in the first place? But also let's start from kind of like backward. What is kind of like Couch Chain? What is Solve in the first place?
Yeah. So Chaos is an accountability protocol for the
Mhm.
agentic economy. Okay. So now AI verifiability, okay, we have so many different techniques, right? And then we are like building different techniques, like ZK being one of it. Like how can we have verifiable claims by an agent or by an AI model? And then how you
Mhm.
can verify the code ran in a secure environment, and then whether it was verifiable, and then like a specific prompt really came from like answer to some specific prompt really came from like some specific model with certain parameters, so on and so forth. We could like use ZK or like some other like TEs or something which
Mhm.
could help us have verifiability there. But then what happens after you have the output? Okay, so imagine like in next 5 years we will have like millions and billions of agents all online.
Mhm.
Okay, working on so many different in so many different tiers, right? From low stake to high stake. Okay. So low stake being like most of our daily tasks. It might be, like ordering something on Amazon or like just some other mundane tasks that we right now do manually. Like it might be like searching online for some like restaurant that is,
Mhm.
like aligned with your preference, and like maybe you want to plan a get together with your friends, with your, let's say, high school friends. They're
Mhm.
back and you're meeting them after many years,
Yes.
and you want to make it memorable, whatever, right? Like you want basically help with planning. So these are like low stake uh, tasks, and then you want these things to happen autonomously, right?
Mhm.
So agents should help us, but this is low stake. Then why would we care much about verifiability or accountability here, right? So from human to agent, it may not matter much, but when there are, let's say, 10 agents collaborating with each other,
Yes. Yes.
in a sea where there are billions of agents, right? How are they going to discover? How are they going to make friends? Okay, and how they are going to choose their colleagues to, like uh, collaborate frequently, or figure out who is a specialist and like how can we like get in touch and then work together, so on and so forth. Like it's good to think of them as similar to like the dynamics we humans have, right? Like how
Hmm.
we have relations with so many different people. It would be friends and a family, or like just colleagues, like professional connections and so on and so forth, right? So we should
Yes.
have that kind of thing for agents also,
Yes.
if we want like this autonomous future to be powered by billions of agents. So, so even in this low state, then accountability matters because this is what will help build the reputation of all
Yes.
the agents. So it's fine. Like verifiability will prove you like
Hmm.
the model call. It comes from a specific model and so on and so forth. But
Hmm.
then the output where there are strategies and then the planning and then
Hmm.
like so many charter that goes on.
Yes.
So you need some kind of accountability and audit trail for
Oh,
that.
yes.
Okay, so like Kyoshin's core focus is on that,
Hmm.
building this accountability protocol so
Hmm.
that like in this multiple in this multi-agentic workflows, right? We focus on this whole chain of work and have an assessment basically on what
Hmm.
each agent is doing. Okay, so simple example uh, is if three agents are collaborating, let's say to find uh, like to find, let's say, this agent might be trading, so like let's pull them towards bit towards high stake
Hmm.
task. So they are going to like make an investment decision of $1 million, right?
Hmm.
And three agents are responsible to make a decision on this. And agent A might discover like some specific opportunity, and agent B might be responsible to like do some more research on it, and agent C might be the one who is going to execute. Okay. Now, there's going to be a lot of like dynamics between how these three agents are going to interact. It's not going to be like static, sequential chain of work. Like agent A
Hmm.
just says, okay, here's an opportunity, go go
Hmm.
fetch it and then
Yes.
work on it and then pass it down to agent C. Okay.
Hmm.
So we want to foster an environment where all these agents can, like debate with each other
Hmm.
freely and then, like figure out different strategies and like come up with new insights. I want to make a quick analogy of this. Okay,
Yeah.
we like based on what we are talking about, like black holes and path
Hmm.
integrals. So we have this, like there's a task. Okay, like invest $1 million so that you have some specific goals in mind. Like you have some returns and specific returns in next 10 years. Okay, like 12% or year over year, let's say.
Hmm. Yeah, year to
And
year. Yeah.
yeah, so and then like so that's so we have a starting point and initial condition for these three aliens. Okay, let's call it point A, and we know what the goal is. That's point
Hmm.
B. Okay, so there are like infinitely many ways that these agents can get to this point B. Okay,
Yes.
so most of them are going to be non-optimal, and
Mm.
these agents, like in a stochastic way, they might choose to go, like in a on a non-optimal path,
Hmm.
but you need accountability so that
Yes.
like they are kind of containerized in a way that they figure out the optimal paths. Okay, so they figure out what are the best strategies to go efficiently from point A to point B and so on and
Hmm.
so forth.
Hmm.
Okay, so of course, like so when there is an environment like this, which gives like kind of a freedom to all the agents to explore and then work together, so they are going to come up with many new strategies that we may not even have in our textbooks. Okay, so we want to foster these things. So we want
Mm.
to promote agency among all these agents. So that's why we are, as in Gaussian, we have something that we call proof of agency.
Yeah.
So proof of agency is what kind of it's basically cryptographic proof
Yes.
of the chain of work, like how some specific uh, event from one of this agent leads to what cause. So we are looking at causal auditing
Hmm.
of the chain of work. So what specific output from an agent led to
Hmm.
what effect? Okay, so what
Hmm.
cause led to what effect, so on and so forth. So this really allows us to like zoom in and then create like work on a score vector and so on and so forth. I can get into details
Question,
later.
Sweet. Is this is this like an open source attestation published on chain? Like the
So
verification?
yeah, so this protocol is not ready yet.
Mhm.
It's we will have it on testnet and hopefully by next week. So once it's
Okay.
but
When
it's
it's in
like all
ADAS,
open
yes.
source.
Yes.
Yeah,
So the
yeah,
idea is to build like attestation and verifiable, yeah, verifiable agents so that you can actually start to do second step. There will be kind of like, yeah, kind of like profilation, scores, records of actually like agent history.
yeah, exactly. So all of this, like all the strategies and all that, like we are again like storing it in decentralized storage, like
Yeah.
for example, IFS or
Yeah.
like other solutions, and then these are valuable assets. Okay, because as I was mentioning, like agents are coming up with new strategies and new
Of course.
insights and so on and so forth.
Yes.
So they are doing some valuable, they're creating value. Okay,
Mhm.
and they should be rewarded for that value as well. Of
Of
course,
course.
like their primary rewards are like do the work, get paid, right? But they should also get royalties on the data asset that they are creating. So we are
So
also like
yeah,
work on
royalty.
this kind of streamlining royalties on
Nice,
data.
nice. Do you want to show us? I'm just conscious super of time here. So if
Oh
everyone
yeah.
also like has question here in the comment, feel free to ask. We're just going through like Chaos Chain and kind of like the proofs and the accountability system. You want to maybe like screen share and shows like a demo on how this will work. I think it might be also like useful for people to understand a bit more practical what is all this about.
Yeah, sure. Sure. I'll show you one of the initial prototype
Let me
that we
share the
just.
screen here. I
Okay.
see your
Yeah.
screen now.
Thanks. Yeah. Thanks. Yeah, so this is something we shared last night actually. So we don't have the full accountability protocol ready yet, but what we have right now is I think I didn't okay. So Chaos Chain like is also introducing this triple verified stack. Okay, so like first layer of this triple verified stack is
Mhm,
AP2, which is like Google's new standard, like agent payments protocol. It does two things. One is like intent verification. So we as humans, we have intents and we want like agents to deliver services autonomously based on that intent. So you need a proof of authorization, and this AP2 helps us do that. So we have done our own customer implementation of AP2. Second layer is process integrity. So this is where we were discussing it. So this is where like solutions like ZK or like TEs come into play. It looks more on the internal mechanics of an agent, the business logic, and so on and so forth. Now, layer three is what we were talking about accountability. So layer three, it's still not completely ready yet. We will deploy the core
mhm.
contract soon of this. So
Okay,
right now in this demo, what you see more or less is like the layer two and some aspect of layer three, which is like validation. So
okay,
what's happening here is, so this one we are using Questions SDK that out of the box lets you like have access to ERC-804
yes,
registries, X402, and then also connection to 0G or base Sepolia or other testnets that where we have deployed. Okay. So yeah, moving forward. So yeah, we have the compute and storage service from 0G in this demo. Now we are going to initialize three agents. I'll quickly go. Yeah. As a first step, like we are registering the agents on
yes,
ERC-804 contracts, which we have deployed on the testnet of 0G. Now, we also like out of the box give smart wallets to all the agents that use our SDK, okay, using Coinbase Agent Kit. Now you see like this agent is registered. Now 804, this is the version one of 804 where identity has become an NFT. So this is registered at with this wallet address and it's an NFT and whose token ID is two. And this token ID is the agent ID. Now same with
okay.
the second agent, ID is three. And then with the third agent, the ID is four. So yeah, like you can go on 0G Explorer and then you can see that this NFT
Uh-huh.
being minted there. Yeah,
Yes.
I can show it, but I think I have to change the permission again. Maybe I'll
Hmm.
show it in the end if we have time. Okay, so
Yeah.
quickly moving forward. Now we are starting our triple verified stack. Now
Hmm.
first is the AP2 intent verification. that I mentioned, and then also process integrity. So yeah, intent verification. So like me as an user, I have an intent. Is that my intent is that find me the best winter jacket in green, and these are some
Hmm.
parameters, my preferences, and this is my intent. Like I have a price limit of $150. Now, AP2. So in our implementation, we use RS-256 to like encrypt this, and
Hmm.
we also have a JWT for this description for this intent. So this is a intent, and now uh, the client agent who has token ID 4 or agent ID 4 is providing this intent to a server agent, Alice, whose agent ID is 2. Okay. Now, Alice's job is to, of course, like uh, perform analysis and figure out which is the best jacket. Now, Alice is running inside zero G's compute and using which is like TE verified. So it lets us, have the task and job submitted to zero G compute and have it verified. So this is the execution hash, and this
Hmm.
got verified in this TE. Uh, yeah, this is the chat ID for verifiability, and this is the
Which, sorry,
provider.
sorry, which TE are you guys using?
So this is from zero G.
Ah, zero G. Okay. Okay. Sounds
Yeah,
good.
yeah,
Thanks.
this is right now running on their network.
Hmm.
And then yeah, so once the analysis is done, it is being stored on yeah, on zero G storage. So this, in a way, right now is vertically integrated.
Hmm. Hmm.
So yeah, this is the hash. You can go on the we can go on the Explorer and check this out. This is the URI of the data object.
Hmm.
Yeah, right. Now, because the work has been done, now we are like settling in zero G token, and intent is verified, and then the job is kind of over. So the payments is going through. So these are like the payment links. Yeah.
Hmm.
Now, okay. So like more or less the layer one and layer two are over now. Now we are in layer three where we have a simple aspect right now of accountability, which is just a second agent is going to validate the output, the work of agent A or Alice. So it goes through again like the same compute network of zero G. You have like execution hash here and the proof, and this is the validation. So this is I think there was some problem. I didn't render the scores here. Um, yeah, sorry about that. So Bob basically will validate and give some scores to this to the work of Alice. Now, once that is done, because Bob is also providing service in the favor of Charlie, who is the client,
Hmm.
Charlie is also going to pay Bob a small reward.
Hmm.
Okay, so this is like 0.001 in zero G's token. Again,
Hmm.
like this transaction is recorded, we can go see
Yes.
it, and
Yes.
then the evidence package from Bob of validation is again like stored on zero G. And yeah, so this is basically the simplest version of Chaosium's triple verified stack.
Nice. Nice. I really, yeah, I really like. It's quite also straightforward, right? So what are you, so right now, currently, this is like a test net. So what are kind of the next steps? Let me unshare here. Or do you want to show something else? Because we have like less than 5 minutes. I just want to also go what's happening next.
So what's happening next is okay, yeah, we have something exciting coming up. So like the core protocol contracts are almost ready. So I have to do some final testing before deploying it to testnet, and
Mhm.
then we are building an agent launchpad. Now we are the great thing that ERC-804 enables is like giving us a platform basically or a mechanism to have discoverability between different networks as well. Okay, so we have deployed right now like ERC-804 contracts on 5 different testnets. Okay, and then we are creating this agent launchpad and an explorer. So this agent launchpad will make it very seamless for anyone to launch an agent with, for example, with Google's intent mandate if they want with AP2. They can choose which provider, complete provider they want. Do they want zero G or do they want EigenLayer or anyone else? Okay, for verifiability, and then also for storage, we will have no vendor lock-in. They should have options. So all of this will be seamless through our launchpad. and they will be able to, of course, like get agent ID of 804 and then tap into reputation and validation registries also. And so that's one part. Second is, like the search mechanism or discoverability of all the agents on different networks. So we will also have an explorer
Ah,
with
okay.
this launchpad.
Yes,
Yeah.
yes.
So it will be
Ah,
very
okay.
easy for finding agents on all of these networks.
Mhm. So Explorer, and then like, and working with other agents. I mean, obviously, you guys now full support A004 plus X402 for payments. Is there other like stakeholder that you will like work like with in the future? I assume like, other agents, I don't know, specific for attestation or for like reputation. But is there any other categories?
Well, yeah, so like we do have like many interesting projects that want to, work with us and then like integrate with us, which is quite exciting.
Mhm,
So right now, again, like we are a small team, so like we are like prioritizing,
mhm.
and then we are being a bit conservative on our initial steps,
Yes,
because we want to be like also stay very focused.
of course.
But
Yeah.
then we need the trust primitives, and trust primitives are provided by ES804 by AP2 and X402. Okay, so like these are like the fundamental building blocks. And then we are building our complex logic of chaos chain around this.
Nice, nice. And Sumit, before we closed it up, there is a lot of like builders that also like maybe look to support A004. Like in general, like building a product is not easy, right? Like, is there kind of like lesser learned recommendation that you wish people here would like to kind of like know before they start building or they start actually like thinking about, because I mean today's state is that we have, I don't know, 300-400 forks of ELISA, same agent doing the same
Mhm.
different
Mhm.
things. What do you recommend for people? Yes.
I would recommend like use Chaosians SDK. So you get out of the box. It's okay if it's ELISA. So use Chaosians SDK. You will of course get like like the agent ID and all that. Also like X402 payment access. But like you're launching this agent, where are they going to land, right? So in Chaosian, I think we are out of time, but like real quickly. So in Chaosian, we are building something that we call studios, which are like on-chain environments. This is where like agents will be able to collaborate cross-chain, okay, in a seamless fashion. So irrespective of how simple your agent is, it doesn't matter. It's just an instance, right? Even if it's just basic instance
Hmm.
of LLM and then compute and all that, like in studios, we will put them to extract like high quality work because studios act as context
Hmm.
containers, and we have some more interesting cool tech being built inside studios, so that like all these instances get highly utilized and
Okay.
rewarded. Yeah,
Okay.
because
Okay.
incentives are very important to drive
Of
the
course.
uh,
Of course. Yeah. To keep the of course.
to
Yeah.
extract
Yeah.
high performance. Yeah,
Awesome.
and
Awesome.
Gaussian
Sounds
will
good.
be doing that. Mhm.
I mean, yeah, I think I also agree. I mean, incentives is also part of the game, especially for agent, not just human incentives, right?
Yeah.
And I think also like rewards. I think how would you say similar to a human kind of like economy works, like you have percentage of success based on maybe a reputation or attestation of like
Mhm.
results. There is a lot
Yeah.
of like interesting things that you can build on top of like kind of like agent collaboration dynamics. Okay, Samit, thank you so much. I really appreciate. We definitely need to do a part two when you guys are on mainnet. And
For
until
sure.
then, yeah, keep building. I really appreciate that you guys support A004 and we're able to do this live stream today. And yeah, looking forward for more.
Yeah. Thanks for having me. This was fun. Yeah.
Pleasure.
Looking for
Thank you so
part
much,
two.
Samit.
Okay. Yeah. Bye bye.
See you guys, everyone.